Well, okay. I'd like to welcome you all on the second webinar of the DevOps trilogy. I would like to inform you that it will be recorded and we will send it to you later on. And before we start, I would like to tell you a couple of words about SoftServe. So this is an IT company which specializes in software development and consultancy in a field of big data, cloud, IoT, e-commerce, and experience design. It was founded in 1993 in Lviv, and now it hires around 8,000 associates in 11 countries. Here in Poland, we have 5 offices. The headquarters is in Wrocław, and the rest are in Gliwice, Białystok, Poznań, and Warszawa. Today we have 2 hosts, 2 experienced DevOps engineers with, I guess, more than 11 years of experience. They will introduce you to AWS Outposts. So guys, mic is yours, and people have fun.
Okay. Hello. Hi, everybody. My name is Radek. I am working in SoftServe as a senior DevOps engineer. I would like to thank you all for joining this today's webinar. Together with my colleague Piotr, we will be talking today about AWS Outposts because we want to show you the benefits which comes with the outposts and all the technology related details here. Before we start and jump into specific topic, I would like to ask you if you feel to ask us any questions during the presentations. Please feel free so, but do it with a question and answer button in the Zoom communicator. And later on, at the end of the meeting, we will try to address all of those. And if you would like to leave us some contact information, feel free to do so, and we can take the conversation offline. Yeah. So let's start. We will start with our agenda, a short presentation of the topics that we'll be talking about during this presentation. So first of all, we will focus on the on-premises challenges. So all the challenges that comes with the on-premises infrastructure that we are holding. Nextly, we will switch to an overview of the AWS Outposts technology. What is AWS Outpost, where to use it, how can we use it. Later on, we'll switch to getting started. So we will describe a process to getting into the AWS Outpost, how to order it, how to choose proper setup for you, and so on. Later, we will go through the technical details of the on-premises services that can be run within Outposts, together with networking technologies and consideration. Nextly, we'll talk about managed services which are possible to host with AWS Outposts. We'll talk about EKS and ECS for Outposts as well, switching to data center high availability, and we'll be finishing with the security and compliance considerations. So for the first topic, why application needs to remain on premises. So together with the experience that we are getting with working with the clouds, we were able to identify 2 key fields which prohibits applications to be moved to the cloud, which is first of all the latency and vulnerability in latency, and secondly the data processed that has to be processed locally. Please mark here that we are not talking about moving infrastructure into the cloud, but only single workloads, applications. So first of all, when it comes for latency, applications very often need real-time, almost real-time responses, so near to millisecond responses, and this can be problematic when you want to move them into the cloud and serve them from the cloud, because as we are aware, the latency is slightly different, slightly bigger than just latency of an on-premises served applications equipment. The second thing to consider when we are talking about latency is on-site equipment control. So some applications may require that the equipment to be placed on site, for example, for security reasons, for the reasons related with any compliance, like HIPAA compliance and similar stuff. And third reason that is worth to mention is communication with other on-premises systems. So it is easier for us to utilize an application which is hosted on premises, which have to communicate with an on-premise system, like, for example, self-hosted databases or any other equipment related, for example, to factories or other healthcare systems. When it comes for data that is being processed locally, the important part here is the integrity of ingested signal, because very often we have an application which gathers a lot of information from different data sources, like mobile phones, like customer applications, and it's crucial that the signal or the delay in those data that is being imported locally will be very small. Like I've mentioned earlier, processing messages from industrial equipment. So, for example, let's imagine that we are in charge of a factory which has a lot of different devices which send data related to measurements or availability, and this data has to be delivered into the system without any delays. And third consideration about managing local data stores, so something that needs to stay local and to be under special security treatment. Another challenges that may be faced with an on-premises applications are three main areas here. So first of all, the IT infrastructure, developers, and business. So the infrastructure that has to be managed on-premise, first of all, we have to think about the complexity of procurement and provisioning. So we have to, first of all, order this equipment, wait for it, install it, and maintain it later. The complex process of patching and upgrading, because it produces a lot of overhead when we have to patch, for example, different vendors or different systems that we are handling within our on-premises data center, and of course application maintenance downtime, because very often when we use equipment which is placed on site, we do not consider it to be highly available. So every hardware upgrade is producing application downtime. From the developer's perspective, developing application which will be served within on-premises data center and cloud data center very often differs from the perspective of services and APIs. So the developers want to unify them both to be able to create applications which can be easily moved to the cloud and to be compatible with it from the very beginning. The same situation comes with the tool set and the code process for an on-premises infrastructure. And lastly, from the business perspective, keeping the on-premises hardware always influence the innovation, because we are not able to follow all the trends, all the technological trends, or the security and best practices trends the same way that cloud companies does on the daily basis. So thinking about all of those, AWS introduced AWS Outposts. This service was presented during the 2019 reInvent event. And how does AWS define it? Actually, the AWS Outpost is a fully managed service that extends AWS infrastructure, services, APIs, and tools to customer premises. So this is a part of infrastructure which you are receiving, a part of AWS infrastructure which you are receiving to be hosted within your own data center. So what are the key benefits of this approach? First of all, you receive exactly the same AWS designed infrastructure. So you are not working on some kind of random pizza box servers, but you are receiving on fully AWS prepared and AWS maintained hardware on which the current cloud infrastructure is working. Additionally, this piece of hardware is fully managed, monitored, and operated by AWS. We will be talking about more details about how does AWS does it, but it's being this equipment is being operated by AWS by design from the very beginning. And lastly, the single pane of management. So we have a single console within the AWS console to manage all our resources which are located in AWS region and in AWS Outposts as well. Okay, so right now, if once we know what is AWS Outposts, let's check how it actually looks. So it's nothing more than a very large piece of hardware. So you can see here that the cloud infrastructure is not being built with clouds, but with a real piece of very nice hardware, which is placed into a industry standard 42 unit rack. This rack is fully assembled and ready to be rolled out into a final position. So it has every single component that is needed for running AWS Outpost within your data center. It's installed by the AWS, so the plugging into network and power process is being handled by AWS, but with the support of engineers from the side of the data center. This fully equipped rack contains a redundant power conversion unit inside, together with active components, which are also redundant. By those active components, we understand top of the rack switches and of course the server units. AWS Outposts comes with two variants. Actually, it will come with two variants because only the AWS native variant is available at the moment. So AWS native, it's nothing more just about the AWS infrastructure that we all know. So those are the services and features that are known from the AWS cloud. So within this variant, we have the EC2 and EBS instances together with all the services that are supported to be run on the AWS Outpost. And the other variant, which is to be introduced within 2012, it's the VMware Cloud on AWS. As you may already know, AWS has this possibility to host a VMware managed infrastructure within AWS Cloud. And right now they want to introduce the same feature to be placed on the AWS Outposts. So it will be a fully supported and managed VMware infrastructure, which can be extension for the current VMware infrastructure, which is placed within the data center. A couple of words about where AWS is able to ship Outposts racks to. So you can see that first of all, the Canada and USA, all the EU countries together with Switzerland and Norway and a couple of more countries are possible for AWS to ship the AWS Outposts to. More countries will come along the line, so for sure sooner or later whole world will be covered by this possibility of shipping AWS Outposts. What is important also from the Outpost perspective is the regions that are possible to be connected with AWS Outpost rack. So once you order the rack, you have to choose a region to which this rack will be connected. Actually, which region will be extended by this particular AWS Outpost. And here, just to be clear, you are able to choose all the regions to connect, but there is one consideration to think about. The consideration is the latency. It has to be below 150 milliseconds between your location and the AWS region to which you are connecting to. So how to start, actually? So first of all, we have to think about our data center and the requirements that have to be met before even ordering the AWS Outpost. So first of all, AWS requires a standard data center space and power. Regarding power considerations, we will talk a little bit more about it, but the minimum available power for the rack installation is 5 kVA. Another thing is the network connectivity to AWS region. So you have to provide one of two ways for AWS to connect to the region. First way is the AWS preferred but quite expensive, which is the AWS Direct Connect with public virtual interface. And the second one is just a plain internet connection via the default ISP, which is serving the internet connection for the data center. And third requirement is the enterprise support, which has to be provided. It's like 24/7 fully engaged customer support to be able to order AWS Outpost. Here we have a process of ordering the AWS Outpost. So as you can see, more or less this process goes for 3 weeks. It's divided into five points. First one, it's the pre-sales activities, the most boring one. Secondly, we are placing an order submission via the AWS Management Console. So simply within your account, you are logging into the AWS account and choosing a proper AWS configuration of Outpost, which you want to place in your data center. The third step is site assessment and site preparation, and this step is being done together with cooperation with AWS team. And this is nothing more than just a visit from a AWS representative who will check if all the requirements, which we were talking about earlier, are met by the data center. Later on, we have the order approved and installation scheduled step. So once the order is validated, the installation is scheduled, and the installation step itself. So after this fifth step, you are equipped with a fully working AWS Outposts, and all the services that you've ordered are already configured and ready to start working. Let's talk a little bit about the services which are possible to be run on the AWS Outpost. So as you can see, those are the basic AWS services like Amazon EC2 together with EBS, Amazon Elastic Container Services, Elastic Kubernetes Services, VPC, RDS, which is currently in preview, and we'll highlight it a little, Amazon EMR as well. As for the coming soon services, those are S3 and ALB. And just to clarify here, this doesn't mean that you are not allowed to use S3. You are allowed to use S3, but you have to use it from the normal cloud, AWS cloud. So you will simply connect to AWS cloud via the internet or the management service link. Regarding the EC2 and EBS, which are possible to order and to install within your AWS Outpost, all of those EC2s are Nitro-based instances. This is very important because AWS is using only the newest equipment to ship to the data center and to host the Outpost related infrastructure. So as you can see here, we can choose any kind of those instances, like M5 for the general purposes, C5 for the compute intensive workflows like transcoding, gaming, and machine learning. We can choose R5 for the memory intensive workloads, G4, which are mainly dedicated for machine learning and graphics processing, I3 instances, which are input-output operation extensive. Those are mainly bare bones servers, and EBS dedicated for local instance storage and the storage that is attached additionally to the instance created. And this is a limitation that only the GP2 storage is available to be chosen here. Regarding the pre-validated catalog of AWS Outpost configuration, this is something that I've mentioned earlier. When you log into your AWS console, you don't have to start your order, but you can simply view the configurations here, and you can see what kind of configurations are able to be chosen here. What is important here to pay attention to is the power draw, because if you choose a specific configuration, you have to be sure that your data center meets this power criteria, this power requirement, and before you order this particular setup for AWS Outposts. So this is open. You can verify it, validate it by yourself. Additionally, a custom configuration is also possible, but it has to be consulted individually between you and a partner, for example, like SoftServe, or directly to AWS. Let's discuss shortly networking aspects of AWS Outposts. So as I've mentioned earlier, we can consider AWS Outpost as a kind of extension to VPC, which is placed within AWS region. So as you can see on the left-hand side, you have a normal AWS region with 2 availability zones and with some subnets inside of it, and all the other components that are normally deployed there. I won't describe them because you are probably very familiar with them, so let's not waste time for this. And at the right side, we have AWS Outpost, which is placed on premises and also has a different kind of subnets inside. What is important here is that Communication between the subnets is possible within Outposts together with communication with other subnets placed within the region. So this is exactly the same how it looks like within a single region of the AWS. What is interesting here and what AWS introduced with the AWS Outpost is the local gateway instance. Actually, this is a kind of a gateway which is dedicated for communication between AWS Outposts and other on-premise systems. So for example, you can use it to connect to your local workloads, you can use it to connect to the internet, and even you can use it for connection back to the AWS. As you can see on the example here, we can use exactly the same routing policy and strategy that we know from the AWS. So we have local targets, which are actually the local subnets. We have the default destination, which can be, for example, internet gateway, which is placed within the region. This means that all traffic, even the internet traffic from the on-premise, will be routed through the AWS region. It's not very common and cheap solution because all the even internet traffic will have to go through all the instances within the AWS. And for this particular reason, we can use the local gateway itself, together with other types of connectivities like virtual gateways, transit gateways, and so on. It's all configurable at AWS Outpost side. Right now, let's focus maybe on the connectivity between the Outposts and the AWS region itself. As I've mentioned earlier, we have two possible ways to connect between the AWS region and customer on-premises data center, which is the direct connect installation through the WAN, or just the internet service provider, which is providing the internet connectivity to your data center. This connection is very important because AWS Outposts uses it for the service link. Actually, service link is a very important part of the setup, because within the service link, communication with AWS backbone is being introduced together with communication with other, for example, EC2 instances that are placed within the VPC. So two types of communication: the management. So within the service link, AWS is able to manage and monitor, backup your AWS Outpost, and your instances located with AWS Outposts are able to communicate with other instances or other services within the VPC in the particular region. So as the global explanation of the network and performance and the key takeaways that I would like you guys to remember from this part of presentation is, first of all, the networking part. So the Outposts network devices, so those devices that are responsible for connectivity to other on-premises infrastructure and to AWS infrastructure as well, comes with 4 predefined capacities. Those are 1, 10, 40, and 100 gigabits per second. Instance to LAN communication, this bandwidth limits, actually, this is only limited by the customer link. So actually, this is no limitation from the Outpost side. This is only a limitation from the customer network side. Instance to instance bandwidth limits, those are the limitations that are valid for AWS infrastructure as well. So this is purely determined by the EC2 instance family, because different families comes with different ENIs, so the different throughput between instances can be established by this meaning. And the thing to remember that we've talked previously, the maximum latency to region, which should be less than 150 milliseconds. The other thing to mention is the service link details. This is this link which I've marked as important between AWS and Outposts. Two types of traffic are forwarded through this link. So management traffic allows Outposts to work as the managed services, and the data traffic dedicated for normal workloads. A consideration regarding the default route can be through the VPC, so we can forward all the traffic through the VPC, which will flow through the service data link, but forwarding it through local gateway will be much more faster and more relevant. One more thing to remember about the DHCP and DNS provided with Route 53, local caching at the AWS Outpost is able to be configured. It can be done with just a single DNS instance, which will work as the DNS forwarder in case of any issues with service data link. Okay, at this point, we are starting the next topic, which is the AWS Outposts from the perspective of managed services. As remember, I've highlighted a couple of managed services that are possible within AWS Outpost, and I would like to describe the first of it, which is AWS RDS databases. This service is currently in preview mode, but it's already available for the customers with limited capacity and functionality. One of the limitations is that it supports for now only two database types, which are MySQL and PostgreSQL. For now, for sure, other databases will be added here, but still, as this is just a preview, only two of those are possible. So what is actually Amazon RDS? This is nothing different from the RDS that we know from the AWS cloud. So fully managed database with this difference that is hosted on premises within AWS Outpost. It's of course highly scalable and performant. Actually, it provides also the availability and durability the same as the AWS RDS hosted within AWS cloud. So all the related stuff to cloud, to health monitoring, that helps to detect and revoke unhealthy instances, provides automated backup and snapshot and restore. And the last thing is the unified interface, which is with which we can use the same familiar AWS console and CLIs and APIs to manage this RDS instances. From the architectural point of view, this is something very similar that we saw on previous slides. So you can see here that on the left side hand we have the AWS region with the Amazon RDS actually backbone and management part, and on the right side hand we have the AWS Outpost placed within the corporate data center. With the possibility to extend the VPC between the AWS region and corporate data center, we are able to place an elastic network interface, the ENI, inside the subnet hosted by the AWS Outpost, which can be easily used by the application hosted within the corporate data center. And this allows us to drive the latency really to the millisecond and to allow our workloads to work really very proficient. About the service link, which is established between AWS region and Outpost, it is being used by the RDS for the, first of all, database management purposes. So AWS manages our RDS instance from the perspective of failure detection and similar malfunctions. Additionally, it backups it with the automated backups, gathers all the metrics which are placed within AWS CloudWatch, and later on they can be processed for further monitoring. And of course, it's gathering all the logs related to AWS RDS. So at this point, this is all from my side. Right now, I am giving the microphone to my colleague Piotr, who will lead you through the rest of the presentation. And thank you very much. This was all from my side.
Thank you, Radek. So, hello, my name is Piotr. I would like to start to talk about AWS EKS and ECS for Outposts. So probably there are some. Okay, sorry, because we had some technical issue. Okay, no. Okay, sorry. So going back, AWS EKS and ECS work for Outposts. So there is a small difference in architecture between a regular EKS and cluster on AWS and Outposts. So first important thing is that in region, I mean in regular cloud, AWS cloud, is located a whole control plane. So briefly speaking, Kubernetes master nodes and EKS whole control plane. So on Outpost, what we have are located container instances in ECS case and EKS workers in Kubernetes case. So whole traffic between control plane and data plane is done via or internet connection or direct connection, depends on which connection you will use. So Radek mentioned about it before. So application traffic is isolated to Outposts and to local network. So we can run Kubernetes in Outposts locally and communicate with our local application as well. So MI images and ECR Docker registry are located in region, but are cached locally in Outposts. On this picture shows how does it work in Outposts. So we see in Outposts worker nodes are located, but also there is a subnet in common virtual private cloud. So in regions we can see other subnets with Kubernetes masters with Kubernetes control plane. Going further, we have also possibility to run load balancers, but there are some constraints. Application load balancer can be run only locally inside our cloud, so we can't go outside of the AWS with our load balancer. Network load balancer will be run in region. That means entrance will be performed in regions, and then will target to our outposts. So that means whole traffic will be redirected from regions to our targets in outposts. So what will happen if we will lose a connection with AWS cloud? So our instances still will be in operation state, so we will not disconnected totally. So inside Outposts, everything will work properly, but we will lose administrative functionality. That means we will not have our worker nodes will not have access to a control plane like etcd database or other services running on Kubernetes master nodes. Another topic is Outpost high availability, or generally AWS highly availability. So we can run in one data center 2 independent Outpost racks. So we will reach HA on a data center level. If we would like to go further and have 2 independent data centers with under our administration, we can run in our second data center Outpost as well and connect everything together to AWS regions. Another very important topic is Outpost pricing. So how we will manage our billings. We have 3 years contract and we can partially upfront, all upfront or no upfront. Price including, as Radek described you before, delivery, installation, servicing, and removal. So we pay for installation and we pay for whole stuff, whole hardware. We can upgrade our capacity mid-term. Additionally, we can manage, we can run a managed service locally on Outposts. So we are charged only for usage of managed services. There is no additional costs after installation of our Outposts racks. Data transfer charges, also it's a very important topic. So from Outpost to our AWS cloud to regions, we are not charged. From region to Outpost, it's the same price as we pay as in regions. Outpost to local gate, there is no charge. It's very important when we configure our solution, our application, and AWS advise us to run application via local gateway. So briefly speaking, having Outposts, we should use our local network connection because it's cheaper. We don't pay for it. In other case, put whole traffic through direct connect and then using internet gateway on AWS side, we will be charged and it's more expensive. Outpost security. We have 2 levels of security. So we have physical security and software security. So Outposts offers us built-in tamper detection, locked doors in our rack. So this is physical security. Additionally, data Outposts is encrypted. So it's very important because it's encrypted using hardware security keys. and even if we will get out one of our servers from this rack, data will be destroyed. So what gives us AWS as a physical security, and what's our responsibility? So we still responsible for our data. What does it mean? We are responsible for all stuff which what we store and manage on our cloud. Snapshots and AWS images are stored in regions, so we have only local cache. Radek also mentioned about Nitro. Nitro is dedicated hardware of AWS. So Nitro key give us a digital encryption whole solution. And there is tamper detection as well. So physical and type always we know AWS know what is going on with their hardware. Outpost security and compliance. So there is updated responsibility model because usually we can check on AWS web page responsibility model. So there is strict division between user responsibility and AWS responsibility. In this case, there is updated model because customer is also responsible for physical security of this solution. So AWS is responsible for securing infrastructures. That means all run infrastructure services, managed services are still managed by AWS. So also AWS perform separate evaluation of delivered solutions because, as Radek mentioned, they provide hardware and then they perform evaluation of whole solution. So thank you for your attention. If you have any question, please feel free to ask us now.
So I think if there are no questions, we can go to an end. Thank you, Radek and Piotr, for interesting presentation and all participants for being here. I hope you enjoyed it, and I would like to invite you to the last but not least part of the DevOps webinar about managing Spinnaker using Terraform, which will be next Wednesday. Thank you very much.